Okay, so before we even begin, I'm going to just go through sound real quick. Here's the basic sound strategy that I used. So I used the base class, which calls all of these functions, having them defined as blank. The muted pretty much mimics this, except it has a muted constructor which does nothing at the moment. Unmuted goes forth a little bit more crazy. So in its public, it has its unmuted as well as a boolean for beat playing. And here's where I handle the actual centipede playing. So I include all the factors since I use the command pattern to collect the specific sound pointers to throw into the executable stacks. And those are just recalled here to be sent out. So on a construction, beat playing is false because you're going to be starting out in muted mode anyway. But each one essentially calls their respective factories report sound, which then just sends their thing to their class. Oops. So here are the base cases for sound itself. So let's pick up at an actual header. So here we include the command base from command sound, from command score, and then we override the executable to only have play and stop. And the same goes for here, which is sound loop. It does the exact same thing, but it calls forth the command sound execute and sound stops, and it's derived from that. And from there, in actual sound manager, we have let's check this out real quick. So here's where we actually define all of the sounds themselves, and then we create stacks for them to be sent to. And from there we have process functions to go through those stacks and either call start or stop. And we also create 3 sound objects for each of the sound. We have a current sound object and the muted and unmuted. And here's what we had in the demo, which was an enumeration class for the sound event and the sound loop. And then we have the static void functions called send sound command, or loop, or stop loop, so that any of the sound types or command sound patterns could be sent to their respective stacks to be processed. And below that we have instantiate and swap, which are most important, and past that are essentially all of the calls from the sound object class, all the functions, but they act as accessors essentially. So in the actual class, upon construction, we first call instantiate to create the objects and set it to muted, and then upon the sound manager's construction, we fill out all of the sound noises, and then we in the gets functions for the actual sound commands are the enumerations for whichever one you're calling for to set that specific command sound to that specific noise, or not specific, to that specific sound. And then here is the send sound commands, which literally sends it straight to the sound, to their stacks. Process sounds calls the private version of that, and the private version, depending on which one you have, is either execute, which will play it, or stop sound, which will stop it. And the way that works is it goes through the whole stack constantly and calls whatever is there. And then here's swap object, so if it's in muted mode and swap is called, then it switches to unmuted, and so on and so forth. And then these are all just the accessors to the others. Alright, so now that sound management's out of the way, let's go straight to Blaster real quick. So Blaster has a similar strategy pattern in that here's the base input controller base case, and then from there we could derive it into a keyboard. And keyboard looks like this. So it overloads its constructor with a blaster input or a blaster pointer so that you could connect it to the actual ship. And here, during both constructions, you're registering the key input so that any of the WASD just calls to the actual functions within Blaster itself to cause the movement or fire, and upon instruction you deregister the input. And these are created by a actual factory, which is here. As you can notice, I don't do a static stack like I have been forever and a day ago, but within here we essentially just have the create and recycle functions, which can be seen here, which is what we've been working with all for the whole quarter now. Which essentially, if it's empty, you create a new one, set its external management so it's destroyed to do whatever is within mark for destroy, but specifically recycle it back into this pool. And then the cleanup for this pool is called terminate, which then calls a deconstructor, which will clear it out and delete all of its items, and then finally set its pointer to null. We have a very similar thing with AI, or somewhat similar thing with AI. So here's the H file. It has void functions for the diagonals and standstill, and it takes in a private for iterator as well as each of the directions. I'll explain that in a second. So again, very similar with the overloaded constructor taking in the actual blaster pointer, so it's connected to a physical ship. Each of the movement functions calls forth an iterator, and that iterator takes a random percentage of your maximum, which is 40, or your minimum, which is 12, and that's essentially how long that said function is going to be moving, and that really comes to play in updates. So you're always going to be constantly trying to fire, and you're also always reading your current player's Y position, so that if you're reaching a specific bound of the player space, you'll if you reach a specific player bound, either the top or bottom bound, it will call a random choose as to which move you'll choose next, which is all dependent on if you're the top bound or lower bound. And then the iterator itself, upon reaching 0, will call for a new movement to choose from, again with a random choice of 5. And then here is the most important part. So as long as the iterator is above 0, it'll constantly call to the player's functions and apply the actual integer passed in via whatever movement. And if we take a look at that real quick, we can see here's initialize. So here's the actual input mode. So it takes in a Boolean for which mode, and upon being true, you get your input is set to keyboard. Otherwise, it's set to AI. Destroy. There's update. Here's so within each one, you take in the specific integer of either 1 or 0, because the movement is actually applied via multiplying the blaster speed by that 1 or 0, as well as a movement lock, because the actual death function, instead of rather destroying the player altogether, it switches it out into the explosion sprite and calls forth the specific alarms to call repair mushroom, which then in turn will eventually recall respawn to turn the movement lock back on and moves the sprite back to its original position, and so on and so forth. The actual bullet itself is observer pattern, in that the player could always be firing. Let me get that fire real quick. Player could always be firing, but it'll only fire if it's loaded and alive. So alive is, of course, if the player's alive itself, because there is a slight delay between respawn and yourself. But the get loaded status is all handled by the blaster, the bullet, which the blaster is observing. And from there, it's all handled within its destroy to set itself to true or set itself to false upon initialization. And we can do a quick run through. So pressing 1, it starts out in mute mode, so you have no noise playing, and then pressing 1 will activate noise. And actually dying will cause the respawn to occur. So, health there. So you also have 3 lives as you require, and upon complete death, we're sent back to the attractor mode. Exit right now. And from there, we could go into the actual factory. So let's look at the bullets factory for now. So here we have it set up as a singleton, so that it only creates itself when one of its functions is called. And with that, it then also has to properly delete itself upon the game terminating, which is set up with terminate as well as destructor. So deleting itself would then call the deconstructor to empty out all of the the recycled pools, and call pop and so on and so forth. And then its physical constructor only sets loaded to true, so that you could fire, or whatever player is there when it first calls fire, it is able to fire for the first time. And it grabs a sound pointer towards its respective sound and sets that up within a report sound command, only for the sound manager to handle later. Let's see, where are we? Oh, we're decent on time. So from there we could then check out mushrooms real quick. We'll check out mushrooms real quick while we have time. So for this one, we are just going to look at the base class real quick. So in the base class, we have the repair, initialize is poison, and return to position. Or why do I have that? Anyway, yeah. So we have all of these here, essentially so that Mushroom could use it when it interacts with other things. So this just calls for the boolean to return its poison as well as health. It's always initialized to have 4 health specifically, and this just returns its position. And when derived into the actual mushroom, the only real thing that we're adding to it is repair health and initialize. But upon construction, we always set is poison to false, and mushroom health, which is taken in from our common file, which we'll go over later, is externally a constant int, but it's always 4. So mushroom constructor constructs the mushroom, setting up its sprite and colliders and such. Its initialization essentially moves it to the proper position that it needs to be in, as well as make sure that its health is the correct 4. The draw just has the regular draw. And here, upon destroy, we reset the health to 4 and deregister collision, which helps out with what's it called? It essentially resets it for